Hello my dear friends, my dear children, please welcome to my channel Sudhir Chemistry. This is a part 2 in thermodynamics. I am going to discuss about thermodynamic variables. We can say it is called as a thermodynamic properties, or we can say it is also called as a thermodynamic parameters. So thermodynamic variables, thermodynamic properties, thermodynamic parameters. So these thermodynamic properties is of two types. The first one is a extensive property and other one is intensive property. So what is the extensive, what is the intensive, we'll see by the differential. The property which depends upon size, or we can say amount, or we can say mass. The property which depend upon the size or depend upon amount or depend on mass are called as the extensive property. But intensive property means it does not depend upon all these one: size, amount or mass. We'll see the example for this one. What are the extensive property and what are the intensive property and how to remember these examples over it. So the very good example for this one, amount means, or we can size, amount, mass means, directly we can say the mass means it is a property, it depends upon the particles. Instead of saying the mass, I can say the property will depend on size, amount, or it depends on the particles are called as a extensive, and it does not depend upon the size, amount, or it does not depend even on the particles, then it will be called as an intensive. So let us say for example mass. We are considering the mass. Just I want to give one simple example here. I have taken this kind of a wooden stick. I have taken 5 wooden stick I have taken, and let us consider this all the 5 wooden stick together will make a mass of 50 gram. Now I will do, among the 5 stick I will take out one of the stick and I kept only as a 4 stick. And now I will ask you, what is the mass of the 4 stick? Obviously it is a 1 stick of 10 gram is total 5 stick of 50 gram. Now 4 stick of get the mass of 40 gram. Now by taking out the 1 stick, mass changes. Means what you can say, it is a property, mass is a property which depends on number of particles, it depends on size, it depends on amount. So it is a property which depends upon the amount of, or the property which depends upon the size, amount, or the particle will be called as a extensive property. So in this one I am going to discuss the example of here. Mass is the one of the example come under extensive property. Same way, volume, extensive property. Number of moles, that also extensive property. Again we can say heat capacity. What is the heat capacity? We are going to learn in this chapter only. Amount of heat required to raise the temperature for the given amount of the substance, or the amount of heat required to raise the temperature by 1 degree for the given amount of the substance are called heat capacity. Or we can say energy is also a extensive property. But here energy we are discussing in this chapter, either it is a heat energy or we can discuss it about the work energy. And this energy which we are going to say about extensive property means this energy is in the form of S, H, E and G. This is a way to remember. S indicate term entropy, H indicate enthalpy, E indicate internal energy, G indicate gives free energy. So these all the terms will come under the extensive property. So once again my dear children, listen here. What is the extensive property? The property which depend upon size, amount, particle are called as the extensive. Example for that one is mass, volume, number of moles, heat capacity. Energy means heat energy, work energy, and this energy is in the form of what? SHE, G, entropy, enthalpy, internal energy, and gives free energy. So these are the examples. Please remember here 1, 2, 3, 4, 5. With this 5, the remaining 4, total 9 examples will come under the extension. Some more are there that we can find out, but this is the most important example they used to ask in our competitive exam. The other part we are going to discuss about intensive. Property which does not depend upon size, amount or particles are called as intensive. Very good example for that one we remember density. We can say viscosity. We can say refractive index. We can say specific heat capacity. Now what is the heat capacity and what is the specific heat capacity, that part we are going to learn in our topic in this chapter only. But heat capacity and specific, it is amount of heat required to raise the temperature for given amount of the substance. Amount of heat required to raise the temperature for 1 gram of a substance. If it is for 1 mole, that is molar. For 1 gram specific. So density, viscosity, refractive index, specific heat capacity, these are the example of intensive property. And one more very good and common example I want to tell you, concentration. But it's a very important term that concentration is also the example will come under intensive property. Let us say concentration means what? But I can discuss here capital M, molarity. And you know molarity is nothing but the number of moles present in a liter of a solution. But one more point you remember here, this N means number of mole is the example of extensive, V is volume. Extensive means one part was clear that ratio of two extensive property become a intensive property. Ratio of two extensive property become a intensive property. So in this concentration term we are going to discuss molarity is one example, molality is one example, normality is also one of the example. We'll cover about the concentration of this solution. At the same time, I want to discuss one more part here. I'll rub this part. Molarity, molality, normality, mole fraction, all are the example will come under the intensive property. One more example here. Molar entropy. Molar entropy is also the example of a intensive property. Molar entropy means it is a ratio of entropy in a mole. We know that entropy is extensive, number of moles is extensive, ratio of two extensive become a what? Intensive property. So these are the few examples about the extensive and intensive property, and the way to remember I told you here. Property which depends on number of particles and property which does not depend on number of particles. Which depend on number of particles are the extensive, which does not depend on the number of particles are the intensive. So these are the few examples I have covered here about the thermodynamic variables or the parameters. Thank you my dear children.